Yucatan Chicxulub crater may have been caused by binary asteroids. This is what a research group suggests. And this is a picture of them you can see. We have double asteroids like this in Canada as well. And this is one of the examples you can see here. Sometimes they strike one on top of the other, sometimes next to each other. This is on phys.org by Bob Eureka. Example of overlapping craters, most likely created in close binary asteroid impact. A team of researchers from the UK and Australia published a paper in the journal Earth and Planetary Science Letters, this is the image that we are given by them, suggesting that the crater of Chicxulub in Yucatan off the coast of Mexico may have come about due to the impact of binary asteroids, those that travel in pairs, rather than just one single one. The crater is thought by many scientists to be evidence of asteroid strike that led to the extinction of the dinosaurs 66 million years ago. Now, from what we learned recently, the asteroids don't come in alone. They're usually binary or they come in groups. Binary asteroids are not wholly uncommon. Space scientists estimate that as many as 15% of those observed are binaries. This observation has caused scientists problems, though, due to the dearth of evidence of binaries striking Earth, as few to 2 to 4%. And this new researcher team led by Katrina Milkovic suggests that many of the craters evident on the surface of our Earth are believed to have been caused by a single asteroid, may in fact have been caused by binaries. They say that a binary could cause just one crater if the two asteroids were close enough together when they struck. They suggest such craters will likely have a peanut shape or have one side distorted. The team came to these conclusions after building computer simulations that showed asteroids hitting the Earth. Some of the craters that resulted were oblong or irregular shaped, which they say means the same could be true of real craters here on Earth. They point to the Yucatan Chicxulub as one example, which such an example, which many scientists believe is a scar left behind by an asteroid strike so violent it caused the demise of the dinosaurs. They note that the crater has some asymmetries that could be explained by a binary strike. If that were the case, they further suggest it likely that the combined size of the asteroid would have been roughly the same as the calculated size of a single entity, namely a combined diameter of 7 to 10 kilometers. The crater left behind has a diameter of approximately 180 kilometers, which means the researchers say that twin asteroids could have been as far apart as 80 kilometers and still produce a single crater. The researchers suggest scientists will have to take a new look at another existing craters to try to determine if they too are possibly the result of binary strikes, and if so, recalculate their number. Likewise, other scientists might also begin to ponder the doubly hard problem of preventing future binaries from striking our planet. And then studies suggest that dinosaurs were killed off by more than one asteroid. If that's the case, Lynn Edwards, phys.org, of course, dinosaurs, along with over half of the other species, became extinct at the end of the Cretaceous period about 65.5 million years ago. Many scientists believe this was due to a single impact with an asteroid that hit the Chicxulub, Yucatan, Gulf of Mexico area. Now a study published in the Geology Journal proposes the impact that produced the Boltish crater in the Ukraine may also have been involved in the extinctions, and there may have been a shower of asteroids or comets. Meaning all over the world. Professor David Joly of Aberdeen University in Scotland and Professor Simon Kelly of the Open University led a team studying the Boltish crater of Ukraine, which was discovered just recently in the year 2002. The Boltish crater is only 24 kilometers in diameter and therefore much smaller than the Chicxulub at over 180 kilometers across. The team studied fossilized plant pollen and spores found in the mud that filled the Boltish crater and found that ferns colonized soon after the impact in the area, but there was another colonization, a meteor above the first, suggesting a second asteroid impact had occurred elsewhere, causing great repeat devastation. The researchers attributed this second spike, which occurred 2,000 to 5,000 years after the first, to the aftermath of the Chicxulub impact. Ferns are known to colonize devastated areas rapidly after disasters, so layers of fern spores, known as fern spikes, are considered to be good indicators of impact events in the past. The theory that an asteroid impact caused the extinction of the dinosaurs and other species was first put forward again just recently in 1980, at which time it created a great deal of controversy until the crater at Chicxulub was discovered and dated at 65 million years ago. Other theories for the mass extinction include enormous volcanic eruptions of the Deccan Traps in India about the same period of time that would have spewed toxic gases into the atmosphere. There's also a theory the asteroid impact triggered global earthquakes that in turn caused the Deccan Traps eruptions. Professor Kelly said it is possible evidence will be found in future for more impact events around the same time, suggesting dinosaurs may and many other species may have been wiped out due to the effects of an asteroid shower lasting thousands of years. Can you imagine? And new blow for dinosaur-killing asteroid theory. The enduringly popular theory that the Chicxulub crater holds a clue to the demise of the dinosaurs, along with some 65% of all species 65 million years ago, is challenged in a paper that was published in 2009 at the Journal of Geological Society. The crater, discovered in 1978 in the northern Yucatan and measuring about 180 kilometers across in diameter, that's 112 miles, records a massive extraterrestrial impact. When spherules from the impact were found just below the Cretaceous Tertiary, the KT boundary, it was quickly identified as the smoking gun responsible for the mass extinction event that took place 65 million years ago. It was this event which saw the demise of the dinosaurs, along with countless other plant and animal species. However, a number of scientists have since disagreed with this interpretation. The newest research done by Golet of Princeton University, New Jersey, and Thierry Adat of University of Lausanne, Switzerland, uses evidence from Mexico to suggest that the Chicxulub impact predates the KT boundary by as much as 300,000 years. Keller and colleagues continue to amass detailed stratigraphic information supporting new thinking about the Chicxulub impact and the mass extinction at the end of the Cretaceous. This is what H. Richard Lane, Program Director in the National Science Foundation and the SF Division of Earth Science, says, which is funded this research. He says the two may not be linked after all. From El Penon and other localities in Mexico, says Keller, we've known that between 4 and 9 meters of sediments were deposited to about 2 to 3 centimeters per 1,000 years after the impact. The mass extinction level can be seen in the sediments above this interval. Advocates of the Chicxulub impact theory suggest that the impact crater and the mass extinction event only appeared far apart in the sedimentary record because of earthquake or tsunami disturbances that resulted from the impact of the asteroid. Quote, the problem with the tsunami interpretation, Keller says, is that this sandbox complex was not deposited over hours or days by a tsunami. Deposition occurred over a very long period of time. The study found that the sediments separated the two events were characteristic of normal sedimentation, with barrows formed by creatures colonizing the ocean floor, erosion and transportation of sediments, and no evidence of structural disturbance. The scientists also found evidence of the Chicxulub impact did not have the dramatic impact on species diversities that has been suggested. At one site at El Penon, The researchers found 52 species present in sediments below the impact spherular layers and counted all 52 still present in layers above the spherules. Keller said, "We found that not a single species went extinct as a result of the Chicxulub impact. This conclusion should not come as too great a surprise," she says. "None of the other great mass extinctions are associated with an impact, and no other large craters are known to have caused a significant extinction event." Keller suggests that the massive volcanic eruptions at the Deccan Traps in India may be responsible for the extinction, releasing huge amounts of dust and gases that could have blocked out sunlight and brought about a significant greenhouse effect, in other words, a volcanic winter. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.